Welcome to my Java tutorial. In this video, I want to explain thread and runnable. In this first example, we create two threads. Thread 1 runs from 0 to 10 and print out T1 and the E. Thread 2 does the same, but here we print T2. We create an object of thread, new thread 1, 2, new thread 2. Thread 1 started, thread 2 started. We run it. And we see T1, 0, T1, 1, 1, 2, 2, 1. The two threads are run 10 times. The next example is almost the same, but now we implement Runnable. Again, from 0 to 10, thread 1. Here also, from 0 to 10, thread 2. Here we have another thread, thread 3, but with the lambda expression. But the same code, from 0 to 10, thread 3. Start 1, 2, 3. We run it. And we see thread 3, thread 2, 1. All the threads are run one by one. In the next example, we do join. We create one thread with the lambda expression. We create a second thread, also with lambda expression. We start the first thread, we start the second thread, and then we do thread 1 join. What does that mean? The main class waits for 1 to finish. Next example, we explain setDaemon. We have a daemon helper implements Runnable, while count is less than 500, sleep 1 second. Here count plus 1 mean. Daemon helper is running. Use thread helper, run, sleep for 5 seconds. Use thread helper done with execution if we need. We go to the main class. We create the first thread, daemon helper. We create the second thread, use thread helper. setDaemon, for now we leave out. We start the first thread, we start the second thread. We see what happened. As you can see, after 1, 2, 3, 4, the use thread helper is done but executed, but the daemon runs continuing. Stop it and we comment out the setDaemon. We run it again. Now 1, 2, 3, 4. The thread helper is done and the main class stops. The next example is setPriority. We create a thread, current thread get name, thread current thread get priority, print it out. Then we set the priority to max priority and print again the setPriority. We run it. You see the name from the first thread is the main. Get priority 5 is default. We set it to max and then again we print out 10. In the next example, we prove that list is not thread safe. We create a thread and add E to the list. We create a second thread and add E to the list, to the same list. We start both threads and join the that both threads, so we wait until finished. Each 100 times. What mean that the list have to contain 2000 items. And finish. We print the size of the list. We run it. And we see we don't have 2000 but only 1421. We run it again. 1339. Run it again. 1326. Now do that comment, and we use now the collections synchronized list. We run it, and now we have the 2000 items. See, we can run it many times, always 2000. This list is thread safe. This list don't. This example we explain CountDownLatch. We create a class, chef implements Runnable. We have name, this, latch, so this one, and cooking time. We have constructor, and we read all the items. Then we override run because we implement Runnable. We print out the name and the disk. We sleep cooking time, simulate cooking time. We print the name from the chef has finished preparing the dish. Latch countdown. That means -1. We print out counter the latch and finished. Stop. In the main, number of chefs is 5. CountDownLatch, new CountDownLatch is the number of chefs. We create 5 threads, new chef, chef A, create pizza, latch, this one, cooking time, 1000, start. So we make 5, and then latch await. So we wait here until latch is 0. If 0, all dishes are ready, let's start serving customers. We run it. See, chef preparing salad, A preparing pizza, C is finished, counter 4, counter 3, counter 2, counter 1, counter 0, all dishes are ready. Let's start serving customers. This example, we look at CyclicBarrier. We have a final static number of tourists, 5, a static final number of stages, 3, and the CyclicBarrier. New CyclicBarrier, number of tourists, so 5, lambda expression, print out, tour guide starts speaking. So every time all the tourists are on the stage, the tour guide starts speaking. We create a task, implements Runnable. We have variable tourist ID. In the constructor, we read the tourist ID. And in the run method, we have a for loop from 0 to number of stages. We sleep 1 second. We print out tourist with tourist ID arrive at stage. The E and barrier await. Every time all the tourists are finished the stage, we run here. So we print out tour guide start speaking. We go to the main. From for I1 to number of tourists, create a thread, tourist thread, new tourist, I. And we start the thread. We run it. And we see 1, 2, 3, 4, 5 arrived at stage 1. The tour guide starts speaking. tourist 1, 2, 3, 4, 5 arrive at stage 2, the tour guide speaking. 1, 2, 3, 4, 5 arrives at stage 3, the tour guide speaking. After 3 times, the main stops. In this example, we use the exchanger. An exchanger exchanges data, this time type integer, between the threads. First thread implements Runnable. We create exchanger from type integer and read it in the constructor. In the run method, we override data to send 10. First thread is sending data, the data to send, this one. And received data, exchanger, exchange, data to send. So this one, we go into the exchanger and we print it out. The second thread, again, the exchanger, we read them with the constructor. We start sleeping 3 seconds. Here we have data to send 20. Second thread is sending data, 20. Again, the data goes into the exchanger and print out received data. We have the main class. We create an exchanger. We create thread, new thread, first thread, this one, and we put in the exchanger. Then the second thread, this one, and put again the exchanger inside the thread. Start thread 1, start thread 2. We run it. We wait. First thread sending data. Second thread is sending data. Second thread receives the data from thread 1. And the first thread receives the data from thread 2. Example, we use the CopyOnWriteArrayList, whose thread save. We create 2 tasks. Read task implements Runnable. Read task, and in the run, while true, so if you run definitely, thread, sleep 1 second, and print out the list. The write task, again the rest, we give random. We have the constructor, we read the list, and we create a new random. In the run method, also while true, so run as long as we want. We sleep 1, 2, a little bit longer than the read, and we do list set random, and again a random inside the list. So we create a CopyOnWriteArrayList. We put all zeros to start. Thread 1, new write list. Thread 2, again a new write list. Thread 3, a new write list. And thread 4 is the read task. So we write 3 times and read 1 time. We start the 4 threads and see what happened. We run it. You see, we start with all 0, and then 1 by 1, randomly, we put a random number on a random place. This program runs always and always and always until we stop it. In this example, we use the ConcurrentHashMap. Again, that's a map whose thread save. We have a method compute. We put a value inside the map. You see? Then we have a get cast value. Here we read the value from the map. And we have the main. Main started from 0 to 10. The thread number is E, new thread, string key, and thread number, and a for loop from 0 to 3. We read the value from the cache and print it out. We run it. You see, first we have for every key no value, so we put it inside, and after we read all the values from key 1, key 8, key 0, key 6, 9, 5, 3, 1, 4, and example. In the last example, we use a blocking queue. Blocking queue is thread safe and it's in, first out. First, we create a thread who puts a value into the blocking queue. You see it here, task queue put I. We print it out and sleep for 10 milliseconds. Second thread receives a value from the blocking queue. You see it here. And task is task queue take. And we put the value to a method. We look here, and the method print out task being produced by the consumer name and the task. We sleep for 1 second, and then we print out task consumed by consumer name and task. The consumer name is the thread. We have a third thread who also takes a value from the queue, also printed out, and we do if task queue, this one, is empty, we interrupt the thread. Here we do the same. Everything is put in a try catch block, and if we have an interrupt here, we interrupt the thread and we stop everything. Last, we start thread 1, thread 2, and thread 3. We run it and see what happens. Put a little up. So first we create a task. See here, 1, 2, 3, 4, 5, and in the meantime, the consumer is also started and takes value from the queue. You see consumer 1, that's task 1, takes 1. Consumer 2 take the following, that's because it's a first in, first out, value 2, and value 3, 4, 5, and we go down. And if we are on value 20, which means the queue is empty, the program interrupts and stops. This is the end of this video. As always, you can find the code on my GitHub account. Don't forget to subscribe and give a like. Hope you liked the video. See you later.